In today's short video, let's solve Rosalind's bioinformatics stronghold. Third challenge, complementing a strand of DNA. The problem statement says, in DNA strings, symbols A and T are complements of each other, as are C and G. The reverse complement of a DNA string S is the string S raised to the C, formed by reversing the symbol of S, then taking the complement of each symbol, e.g., the reverse complement of GTCA is TGAC. Given an input, a DNA string S of length at most 100, return the reverse complement of S raised to the C of S. So essentially what this problem is asking for, based on the sample input, is that you're given a DNA string, then you simply reverse it, and then apply the complement corresponding to each pair. And feel free to read more information regarding the significance of this particular problem and how it pertains to bioinformatics by clicking this drop-down. There are many different ways to solve this problem, but the approach that is going to be used for this problem is, first, we're going to reverse the entire string. So in this case, given that sample input, let S be that sample input A, and so forth. We're going to simply just reverse that, right? So that's going to yield, in this case, T, G, G, and so forth. And after reversing the original DNA string, what's going to happen is then we're going to create a dictionary that assigns the corresponding key to its complement value. So in this case, that's P equals the pairs. So let's say, just a shorthand, A equals T in this case, and then C and G, and so forth. What's going to happen is then, the third step is we're going to iterate through the reverse DNA string, and then we're simply just going to assign, for example, let's say this key with its complement value. And at that point, at the end of sort of the function, we should have a generated new list that's simply going to have, for example, in this case, S is going to be A, G is going to be C, C, and so forth, right? But since Rosalind's asking for a string, we're simply going to just join that string, which was going to yield that generated sample output. The programming platform that is used to solve this problem is called Replit, and the language is going to be under Python. But keep in mind that you can use any language, use any platform, because the only thing that Rosalind does require of you is that when you submit the solution, it has to follow the sort of same format and everything. And again, this is retrieved from the sample input and sample output from the problem statement. And then later on, I'll explain the time and space complexity that is used or found when solving this particular problem. So let's say we have a variable called Strand string, which will hold this sample input, right? The next is we're going to write a function called Strand complement, which will hold that strand string in this case, right? Because we're passing that in. Well, let's make sure we don't forget to write that function call, right? There you go. And based on our whiteboarding session, keep in mind that our steps that we're going to be doing is first reversing that string, right? By simply slicing that entire string and then just going backwards. Next is going to create that dictionary, which is going to sort of hold all the pairs. Then next is we're going to create a new list, which is iterated over and then assigning the value based on the key from the dictionary created, right? And then we're simply going to join that created list and then printing it. So in this case, let's just say, well, at least in this case, we're going to use the same variable, strand string, right? We're simply just going to reverse that, applying this sort of syntax right here. And keep in mind now, strand string is going to become TGG, CC, and so forth, right? It's not going to be AAA anymore because it's been reversed. Now we're going to write a dictionary called pairs, which will hold, in this case, A assigned as T, C assigned as G, G assigned as C, and then T assigned as A in this case. The next is we're going to create that list and then iterating over it. So we're going to use the same variable name, strand string, which is equals to pairs at I for I in strand string. It's important to keep in mind that this syntax in right here is actually called a list comprehension. That way, we're not writing a for and range loop. We're simply just iterating over the entire string and then, assigning the pairs value based on that given key, right, on the reverse string. The next is going to use the same variable name, strand string, which will then be joined together and then simply print that strand string in this case. So let's see if it should return correctly. So in this case, we have ACC, GGG, and then TTT. So it looks good to me. So now we're going to go to Rosalind, download the data set, and again open that txt file and simply copy and paste that here. But keep in mind that with this code you can technically refactor it, where you're simply just reading a txt file and then generating a new txt file and submit it as that way. But in this case, I'm just simply cutting and pasting, then copying the output in the console, and then simply submitting it. Hopefully it works well. There you go. Congratulations, solved this problem correctly. Now off to explaining the time and space complexity before I let you guys go. Keep in mind that the time complexity is actually O(n), and this is because we're actually doing the reversal and then we're iterating through each sort of character in the entire reverse string. And then the space complexity is actually O(n) as well, because we create a new list right here that holds each character to be set to based on that dictionary.